Hey guys, welcome back to Limitless Learning. Today we'll be talking about an introduction to functions and function notation. So what exactly is a function? A function is a relation between a set of inputs and a set of outputs where each input is related to exactly one output. If you apply this definition to graphs, you could say that a function is where each x value in the given relation has exactly one y value. However, it should be mentioned that one output value can have multiple input values. Let's see some examples to see how this would work. In this question, you were given a set of inputs, shown by the numbers in the oval to the left, and a set of outputs shown by the numbers in the oval to the right. Based on this relation, is it a function? As you can see, each input is assigned to exactly one output, although both 2 and 3 in the inputs have 2 as an output. It was never said that each input has to have a distinct output. It just has to have one output, whatever that might be. Thus, this relation is a function. It's a function. Let's go ahead and look at the next question. In this question, the template in question is the same. Is this a function? If you want, pause the video and try to solve this for yourself. If not, no problem. Alright, so for this relation, something is off. If you look at the input 1, it produces two distinct outputs, 2 and 3, which, as we said earlier, is not a function, as each input must have one and only one output. Thus, even though the rest of the relation seems like a function, this relation is not a function. Although the methods described earlier is an accurate way of testing if a relation is a function, there is an easier way to check if a graph, which again is a relation between x and y values, is a function. This method is called the vertical line test. The vertical line test is where you draw a vertical line throughout the graph, and if a line ever crosses 2 points of the graph, you could say it is not a function, since it is shown that an x value has multiple y values. Let's look at a few examples. So as you can see here, if we draw vertical lines throughout the graph, let's just use a different color. So if we draw lines throughout the graph, there is never a line that has multiple points of the graph intersecting the line. Thus, this graph passes the vertical line test and is a function. However, on this graph, if you draw lines throughout the graph, it seems like every line has 2 points. So for example, on this line, there are 2 points that intersect the main graph. Thus, it has failed the vertical line test and is not a function. Now let's try some problems to see which relations are functions and which are not. Given x and y values, is this relation a function? Pause the video if you feel like you can solve it, but if not, we will go over it soon. Alright, so you should have seen that since each input has one output, it follows the guidelines of what is classified as a function. So, it is a function. Now let's try this problem. I want you to pause the video and try this for yourselves, and we'll come back and go over it. Alright, so if you looked at the table, you could see that every input value except 0, so -3, -2, and -1, all have 2 output values. For -3, it has 3 and -3. For -2, it has -2 and 2. And for -1, it has -1 and 1. Thus, this makes this relation not a function. So it is not a function. Now let's look at some graphs and see if they are functions or not. Once again, pause the video, try the problem, and come back once you have finished. So for this question, you can use the vertical line test. So if I draw vertical lines throughout the graph like this, you could see that no line has more than one point intersecting the graph. Thus, this point is a function. Alright, so I'm going to show you two graphs, and I want you to find out whether they are functions or not. Pause the video this time and come back once you have finished. Alright, so for number 4, something's off. There's no input or output value for 0, if you see there. However, if you do the vertical line test, you should see that each line only has one point of intersection. So there is no point in the graph where it is intersecting at 2 points. Thus, it is still a function. Even though a function might have gaps or parts in which there is no value, it is still a function. So this is a function. So as for number 5, if you use the vertical line test, you could see that the line's in the loop, so outside loop is fine, there is only one point of intersection. But once you enter this loop, it starts to have 2 points of intersection. Thus, it is not a function. Not a function. Now let's try our final problem regarding functions. So now for this problem, since it is a graph, you can use the vertical line test. So as you can see, although every x value has the same y value, since it only intersects at one point in each vertical line, it is still a function, as each line has one point of intersection. So this is a function. So now that we have an introduction to functions, let's dabble in function notation, and let's see some problems. So as you have learned in Algebra 1, functions use the notation f of x equals blank, which is where the function will be placed, whatever that might be. For example, in example 1, the function is 2x plus 5. F of negative 2 and f of 5 is basically asking if negative 2 or 5 is the input, or in this case, the x value, so x is the input in this case, what will be the output? And the output in this case is f of x. Thus, you would substitute negative 2 for x into the equation and find the output. So in this case, you would say 2 times, you would substitute negative 2 for x, so it would be 2 times negative 2 plus 5. And once this is calculated, it would be negative 4 plus 5, which is equal to 1. So f of negative 2 is 1. Similarly, for f of 5, you would substitute 5 for x into the equation, so it would be 2, substitute 5 for x, so it would be 2 times 5 plus 5. And from there, just basic arithmetic. So in that case, it would be 10 plus 5, which would equal to 15. Now let's try a few problems involving function notation. Alright, so in this problem, all that is needed is that you just substitute the given input values for x, like we discussed before, and calculate to find g of x, or the output value in this case. So thus, if you substitute 3 for x into g of x, you would get 28 minus 3 over 2. And if you solve this, it would be square root of 25, because 28 minus 3 is 25, over 2. Now, you could simplify this further because the square root of 25 is just 5. So your result would be 5 halves, or 2.5, depending on how you would write it. Now, as for g of 8, you would substitute 8 into x in the function, and this would result in 28 minus 8 over 2. And that is equal to square roots of 20 over 2. And if we want to factorize the square root of 20, let's just do that on the side. Then it would be 2, 10 to 5. We're just basically breaking down 20 into factors that we can group together in order to make this factor or this radical a bit simpler. So as you can see, these two 2's are grouped together because it's a square root. You can group it into 2's. So it would be 2 root 5. And 5 is just the remainder. It didn't have a group, so we would put this on the inside. So it would just be 2 root 5 over 2. Now, we can also simplify this further because, as you can see, 2 is on the numerator and the denominator. And if something is on the numerator and denominator in this case, we can simplify this further by canceling out the 2's, because this is basically just multiplication, because it's 2 times the square root of 5. Thus, we can eliminate the 2's, and we will be finally left with just root 5, and that is our answer. Thank you guys so much for watching. If this helped you, like the video and subscribe for more content. Leave your comments down below if you have any questions or any ideas as to what videos we should make, and we'll see you guys in the next video.